Section 3.1 is probabilities and percentiles. First in this section, we are going to address this notion of probability. Probability is something that you could take any number of courses on. It's a massive topic in mathematics. We are only going to address the probability that we need for this course. So first, we'll talk about empirical probability. Empirical probability is definitely something you've seen before, whether or not you have heard it called that or whether you remember seeing it. Empirical probability is where we estimate the likelihood of an event by observing how often it occurs. So just as an example of empirical probability, maybe I want to know how often in Boise it rains on April 5th. Or stated another way, for a given April 5th, what is the likelihood that it's going to rain in Boise? So the probability of rain in Boise and I'm talking kind of generally, this is maybe a few days before April 5th, you'd have some sense whether it's going to rain, but I'm recording this video in January. So maybe I'm saying, all right, in April 5th of this year, what is the likelihood that it's going to rain in Boise? How would I estimate this? Well, one natural way to do it would just be go into the records and see how many years I have records of weather data. And so maybe I have weather data back 120 years. So I have something like 120 years of data. And maybe in this data, I found that in 24 of them, it rained on April 5th. And so then I would estimate that the probability of rain on April 5th, I often write probabilities like this, P parentheses. I read that as probability of. Would be 24 divided by 120, which would be 0.2, or stated another way, 20%. So this is what empirical probability is. You want to estimate the likelihood of some event. You do it by observing it a bunch of times or gathering observations of it. And you then figure out how often it occurred, divide that by the total number of times that you observed it, and that is your estimate of the probability of something occurring. Now, this is just an estimate because I don't actually know the true probability. That is, the true probability could be higher or lower than 20%. This is simply an estimate of it. I only had 120 years of record, and it's not the sort of thing we could ever be certain of, right? It's the probability of an event that's going to occur in the future. All right, so that's the first section, is empirical probability, reminding you of how we calculate these things. The next thing we're going to go into is independence and the law of large numbers. And independence and the law of large numbers, first let's talk about independence. This is this notion that you've undoubtedly seen that if you have a fair coin, so that is a coin that will land heads half the time, tails half the time, if you flip it 4 times, and you happen to get 4 heads in a row, this doesn't mean, even though it's a fair coin, that you're more likely to get tails the next time. Your 5th flip, there's a 50% chance of heads and a 50% chance of tails. And the idea here is that independence is referring to the fact that each flip of this coin is independent of any previous flips. So it doesn't matter that you happen to get a bunch of heads in a row, that doesn't mean you're going to get more heads, and it doesn't mean you're due to get a tails. These flips are independent of each other. So that's the notion of independence. Now, independence is kind of referring to individual flips of a coin or individual observations of something. There is a kind of related notion that almost says the opposite thing, which this is the law of large numbers. And the law of large numbers says, okay, yeah, individual observations of some sort of random event, something that's probabilistic, can be independent of each other. Not all events are independent of each other, but a fair coin is an example of things that are independent. But in the long run, the frequency of occurrences of some event will approach its probability. And so let's just state that in the context of this example. The law of large numbers with the same fair coin is saying, but if we flip the coin, we'll eventually get really close to 50% and stay really close. So eventually we'll get really close to half heads, half tails, and we'll stay that close. So if we flip long enough, we'll be within, let's say, 0.1%. That is, we might have within 50.1% or 49.9% heads. And if we wanted to get even closer, if we wanted to be within 0.01%, we would just have to flip long. So that's what the law of large numbers is saying. The final thing we talk about in this section is how we can estimate probability from data. So in particular, how we can take a histogram or a box plot and estimate the likelihood of certain values occurring in a data set. And we also talk about this idea of a percentile. And so I wanted to briefly say what a percentile is. A percentile is just an expansion of this idea of a quartile or a median. So we're taking this notion of quartiles, medians, and saying, hey, we don't really need to restrict ourselves to these specific things. And what I mean by that is that the median splits the data in half. This is the 50th percentile. Now, this is a bad example for defining a percentile because it might be hard to say, well, okay, does this mean that 50% of the data is below or above this? The first quartile is the 25th percentile. That is saying 25% of the data is below the first quartile. And so that means that the third quartile is the 75th percentile. 75% of the data is below that quartile. And once we start with these examples, you can maybe see what I mean, that a percentile is taking these notions that we have and expanding them. We now can talk about whatever percentile we want. So if we talk about the 5th percentile of a data set, this is not one of the quartiles or the median, but we now know what it means. Is the value below which %5 of data points lie. So we have three things in the section: an introduction to, or a reminder of empirical probability, maybe a different term, but something you've seen before. We talk about independence and the law of large numbers, and then we expand our notion of median and quartile to this more general idea of a percentile.